start the recording. And welcome everybody to the introduction to Delta. I'm Jay Alameda from NCSA and from the Exceed project. I am happy to welcome you to our webinar to introduce the new resource that'll be joining this set of Exceed allocated service providers this fall. See if we can go to the next slide, Tim, to get us started.
Right. Thank you for the introduction, Jay. So as Jay said, my name is Tim Warner. I'm Senior Assistant Director at NCSA on a number of different projects. Some of you may actually know me from my Exceed role as well, but today I'll be presenting from the perspective of my role as the Deputy Project Director for the Delta Award. So the Delta Project is an NSF award in their Advanced Computing Systems and Services program. It's what they call a Category 1 system or capacity computing resource. So we are targeting with Delta as broad a swath of the science and engineering, research and education community as we can support. As an Exceed resource, it will be allocated 90% of it through the XRAC process, of which I'm sure many of you are already quite familiar. So I'll give an overview of the project, and as Jay said, I'll hand off to Brett to talk about the system and Greg to talk about applications and user support. If you have questions, we can probably take a few questions in between the different sections, or if you want to save them all towards the end or put them in chat, we'll get answers to you throughout and at the end of the presentation. So Delta, what's in the name? For us, delta is a reference to the Greek letter delta, which in many scientific equations represents change. When we were putting the idea together for the project that would encompass the computing resource, there were three main areas in which we have seen a significant amount of advancement and change in recent years, and that we wanted to incorporate into sort of the work effort that gets put into the Delta project. So you can see them laid out here on the slide. The three areas are computing, where we see, and for many years, there has been a trend towards it shifting from CPU to GPU computing resources for accelerated computing on GPUs. NCSA, many of you are aware, I'm sure, has been a part of GPU computing and a leader in GPU computing since the beginning. So we see that as a continued focal point for Delta, and perhaps now it's even more important than ever. On the data side, we're looking to move beyond POSIX and into more modern file systems that are better performing and more reliable for parallel systems and large-scale parallel applications. So we'll have a file system that looks beyond POSIX and towards something that's perhaps more well-suited to the environment. And last here is the interface. And so we're looking really for, looking mostly here at advances and user interfaces beyond the traditional command line. So we'll have quite a suite of science gateways that we support, as well as our own science gateway interface. We'll also be doing some work on user accessibility to individuals with visual or other types of impairments. So I'll do a quick dive into each of these three areas before I hand off to Brett. So first up here, compute. So furthering GPU adoption. We did quite a bit of analysis of the Exceed allocations that have happened in the GPU space in recent years, and that there's a considerable and growing gap between the available GPU resources in the Exceed portfolio and what's been demanded. Even some science teams we spoke to told us that they had essentially didn't even bother to apply for GPU time through Exceed because they knew that they didn't have enough resources in the resource pool to meet those requirements. And so that really informed our thinking about the Delta resource and the makeup. You'll get a lot more detail from Brett on that. But needless to say, Delta will be the largest GPU resource in the NSF portfolio at its launch. We'll be employing a mixture of GPU types. So we'll have single precision GPUs and double precision GPUs of the latest generation from NVIDIA, so it's the A40 and the A100 GPU. And this really will make the resource overall applicable to a broader array of applications and use cases than if we had selected only one of those GPU types. There's some interesting features even in the A100 GPU that allows you to split up and virtualize the GPUs and create a lot of, I think it's up to 7 individual virtual GPUs on a single piece of hardware. So some pretty interesting features that we're looking to explore with this on the GPU side. From the support side of the GPU story is continuing the work of adapting applications for GPU computing, working with teams to optimize their code to run faster on GPUs. When we wrote the proposal, we anticipated that Exceed would contribute significantly to this through their ECSS efforts, the Extended Collaborative Support Service. And we presumed that that type of support service would continue when the successor to the Exceed project, which many of you are aware, will be ending late next summer. It turns out that's not so much the case with the successor solicitation, which is called Access. And so we'll be working to address some of these shortcomings in any ways that we can from the support angle going forward. Last up is, as a project, we are going to spend some time actually surveying emerging research domains that can take advantage of GPUs, looking at utilization information that's pulled out of either XDMod or other means for getting a sense of the types of applications that are just starting to use GPUs or could be adapted and proactively reach out into some of these research projects and research domains that are just starting to take advantage of GPUs and see if we can assist in any way. Okay, on the data side, one of the things we see in strict POSIX compliance in parallel systems is that there are a lot of challenges in implementing the full POSIX semantics and not losing performance and stability due to some of the limitations and restrictions that the POSIX semantics place for correctness on file open access and locking. And so we believe, and we see that work has shown that reducing reliance on POSIX can improve system performance, reliability, and uptime. And so we are going to, with Delta, provision not just a traditional Lustre-based POSIX file system, but we'll also have a Flash component that will be a modern non-POSIX file system that can present an interface that follows most of the POSIX interface semantics that are used, typical open-close type commands. So it'll look like a POSIX file system, but won't behave exactly like one. But the upshot is that most applications will work without modification and be able to get the benefits of this new file system. So we're looking forward to seeing how that demonstrates the value of modern file systems in these types of resources. All right, last up here is interfaces. So we've partnered with the Science Gateways Community Institute. In fact, we actually presented at their monthly webinar 2 hours ago, this exact talk. So if you were in that meeting and you came back, then well, you must be really looking for some information about Delta, and we're happy to have you a second time. So we're partnering with SGCI on the Science Gateway elements of the Delta project. We really do want to have a really rich variety of interfaces. Traditional command line for batch computing is sort of a de facto standard, but we'll also have open on-demand as a web-based front end to the batch system, and we're looking to support as many Science Gateway communities as we can. So for existing Science Gateways, if you have an interest in getting access to Delta and its GPU resources for that gateway, we're happy to talk with you and see how our system can support the research of your community. If you're not sure if your applications can take advantage of the GPUs, then we want to talk with you and see if maybe if there's some optimization or transition of your code that could support that. Beyond just providing those interfaces, we do want to look at ways to develop system policies and configurations that provide a more harmonious blend of interactive computing with batch computing, on-demand computing that you see in science gateways, and with visualization. There's a number of features in the GPUs that we're hoping can give us some more sort of dials and knobs in the system configuration to make this work a little bit better. And we want to develop some practices here that we can share with the community. Last up on the accessibility aspect of what we want to do. So we have a researcher here at the University of Illinois that we're working with, and we'll have a grad student through him that will be doing a 2-year evaluation and report on the accessibility of the various interfaces that Delta has to individuals with visual or other impairments or disabilities. And so we're going to take the output of that report and use that to improve the interface accessibility for Delta, and we want to share the results of that broadly to benefit as many communities and individuals as we can. We have in here we have a vision statement for science gateways. It's a key part of what we're looking to do. I won't read that, but I will leave that there in the slides for you. A quick note on our project team and project leadership team. Our principal investigator and project director is our NCSA director, Bill Gropp. On the co-PI side, we have Greg Bauer on applications, who will give the third part of our talk. Brett Bodie, leading systems and infrastructure, who will speak next. Myself, Tim Borner, as the deputy project director, and Amy Schul, who many of you, if you've been around Exceed for a while, will recognize has been part of Exceed for a few years ago and going back quite a ways, and working with XRAC and XRAS and a number of other allocations aspects. But she will be our accessibility lead for Delta. And with that, I will hand over to Brett. If there are any pressing and urgent questions, then I'm happy to answer a couple here. We can save those to the end, depending on timing.
So we do have one question.
Yes.
Jay, do you want to read those?
Okay, yes. You want to read that, Jay?
Certainly. From Mark Agney, regarding the non-POSIX file system, would writing silo and HDF files be faster this way?
So first, are there any HDF5 developers on the call? I didn't look to see. Anyway, so I'm not an expert in IO necessarily, but I've been in some projects, sitting in on some projects. So HDF5 was originally written for POSIX file systems and implements a lot of POSIX-like constructs in it. And I know Bill Gropp, you're on the call, so you can always jump in if you want. I know they're working to port HDF5 to the DAOS substrate for things like Lustre. I think that's we used to be originally an Intel project. I think it might be open source now. And so they're trying to find ways to improve HDF5 performance on the, so Silo I'm not familiar with, and so I'd have to get back to you with an answer on that.
All right. Brett, do you want to take it away?
All righty. I will go ahead then. So I'm going to give a quick overview of the Delta hardware. Maybe. There we go. This slide gives a kind of a high level overview of Delta. Our primary vendors are HPE for the compute side of things, and DDN on the storage side, with compute elements from NVIDIA and AMD. So our CPUs are all basically the high end of AMD's Milan generation 64-core processor running at 2.45 gigahertz on all nodes. Then we have GPUs from NVIDIA, both A100 and A40 GPUs, and a node with AMD's MI100 GPUs. We're a little bit different. Those components will be available to other systems in the near future, such as Purdue's Anvil system. But we've taken a little bit different emphasis, as Tim has already mentioned, from current and other previous systems. So we have a lot of systems in the NSS space that have a large number of CPU nodes with a few GPU nodes. But for Delta, with the emphasis on the GPU systems, we've kind of turned that around. And so our emphasis, we've got a lot more GPU resources than we do CPU. So we have 164-bit GPU nodes, which I'll talk about in a minute. Another 100 that are focused on 32-bit GPU performance, and then 5 that have large memory, 2 terabytes per node, and then 8 GPUs per node to enable more scalability within a node for those problems that don't really do distributed scaling very well. And then we have an additional 124 dual socket CPU nodes that are focused on the portions of the workflows that aren't GPU enabled to allow that to be all done on the Delta system. We have an additional 8 nodes that are basically the same configuration as the compute nodes, CPU-based compute nodes that are available for various utility functions, and I'll talk about those again in a minute. And then finally, the storage is provided by 7 petabytes of spinning disk that'll be in the form of Lustre file systems to be augmented in early 2022 with 3 petabytes of flash-based storage. That's where our non-POSIX or relaxed POSIX interfaces will be. That will increase our I/O throughput by almost a factor of 10 over the spinning disk-based file system. So once that's installed, we'll have a very fast and one of the most capable I/O subsystems, certainly for systems of this size in the NSF space. So moving on, I'll talk a little bit about each type of node. So kind of the key node in Delta is the 64-bit GPU nodes. We have 100 of these, and they have a single 64-core AMD Milan processor, 256 gigs of memory, some solid-state storage for the OS and a little bit of local scratch, and then quad NVIDIA A100 GPUs, each with 40 gigabytes of HBM2 memory, all interconnected by NVIDIA's NVLink. So there's a very tightly coupled quad GPU node, and suitable also for scalable distributed GPU computations among multiple nodes. This would be used by pretty much any previous generation code that's run on NVIDIA GPUs in the past, from the very common NAMD and Amber in the molecular dynamics space to TensorFlow, PyTorch, and other ML codes, to a wide variety of other codes. Certainly, these are our most capable GPUs, and as Tim said, they will be available both as schedulable as single GPUs, single node, but also eventually taking advantage of the MIG capability in the A100 to slice it up into up to 7 partitions will allow us to be more fine-grained in the amount of resource that you can request for jobs that don't require a full GPU of A100 capability. In addition to the 64-bit GPUs, we have another 100 GPUs that are configured with the same host node as the quad A100 nodes, but instead of the A100 GPUs, they have a version that NVIDIA is calling an A40. This is based on the same Ampere architecture, but lacks the 64-bit capability and uses 48 gigs of GDDR6 memory instead of the 40 gigs of HBM2. So there's a bit of a trade-off. The lower memory speed reduces performance on some applications. Excuse me, but there's very good 32-bit capability, and it still has the same tensor core capability as the A100. But due to the lower memory speed, your mileage may vary on exactly how much throughput you get out of it. On the other hand, the A40 has a unique ray tracing capability that makes it very interesting for certain types of visualization applications. We expect to set up our queuing and allocate our charging system so that since these are cheaper nodes to purchase, the charge rate on these nodes will be substantially below the A100 nodes. So for applications that do well on them, we expect this to be a lower allocation cost way to get throughput on a GPU node. The dense GPU nodes are basically 8 GPU versions of the A100 nodes. So these have dual sockets, dual 64 core Milan processors, 8 our NVIDIA A100 GPUs, all with 40 gigs of HBM2, fully NVLink connected, and with 2 terabytes of memory. So obviously these can run all the same types of codes that the Quad A100 GPUs can run, but can scale out to more GPUs within a box, and also deal with larger data sets since they have the larger memory in the node. So we expect these to be very interesting for certain types of problems that may not scale out to distributed memory nodes. And then finally, we have our MI100 node. This was put in there as a way for people to test out portability to other GPU architectures. As you may be aware, AMD's delivering GPUs now and later this year that will have very competitive performance with NVIDIA GPUs. They haven't been as proven in the NSS space, so we wanted to provide the opportunity for people to try them out. Later this year, of course, a large system will go in at Oak Ridge with the follow-on to the MI100. But looking at portability with tools such as Cocos would be one way to do it. But we also intend to support AMD's provided containers for things like TensorFlow and PyTorch, which should make this node very usable without having to do any code porting to it for certain applications. On the CPU side, our CPU nodes are kind of standard configuration, dual socket, AMD Milan 64 core nodes, 256 gigs of memory, and a little small amount of local scratch. Again, we have 124 of these, and their primary purpose is to support the CPU-only portions of workflows on the Delta system. We have 8 utility nodes that are configured pretty much identically to the compute nodes, only that these nodes are also connected to our external 100 gig network aggregation switch. So there are data transfer services or login nodes, network routing, and other sorts of things like that, as well as persistent services for users. We're going to have the opportunity to run these persistent services on these nodes for things like either a database or a workflow engine or something like that might need to have persistence beyond the lifetime of a single job on the system, but of course don't use extensive resources on their own. So we will have more information later on how that might work. The storage environment, as I said, is provided by DDN. Initially, it's 7 petabytes of spinning disk split into 3 file systems, home, scratch, and a project-based file system. The project space will actually be split off and is, instead of being connected locally on Delta, will be connected through LNet routers to our NCSA center-wide file system. The Lustre will on the system will support data and metadata for small block I/O to the flash devices within this node, which is of course fairly small by comparison to our later flash, which will arrive in early 2022. The 3 petabytes of high-speed flash will give us a huge boost in I/O performance, as well as providing the relaxed POSIX file system interface. And we'll have more information on that as we get closer to that. But when we go into production this fall, we'll initially just have the standard Lustre-based file systems. I should also note that while we have a 1 petabyte for projects file system, and we'll allocate that as best we can to provide teams with the storage that they need. Teams will also have the opportunity to purchase additional or rent additional storage space in the center-wide file system if that works better than what we can provide. The network for Delta is a Cray-designed HP Cray slingshot network, which is essentially a 200 gigabit Ethernet with some extra functions in it to provide quality of service and throughput guarantees. So all nodes within Delta will have a 200 gigabit slingshot interface. They were connected to slingshot switches with up to 32 nodes per switch. And then the switches are connected in an all-to-all arrangement between the switches, which will provide a very resilient and high-speed connectivity for the cluster. And then at the external networking level, I mentioned that the 8 utility nodes all had 100 gig connections to our Delta aggregation switch, which then has 200 gigs of connectivity to our core network, which externally has 4 100 gigabit links today to national networks such as Internet 2, Exceeds Network, ESNet, and other research and education networks to provide very good connectivity around the country. And at least in the past with Blue Waters, we've very easily been able to confirm that NCSA is not the bottleneck on getting data onto our systems. It's almost always somewhere else. And with that, I will shift over to Greg, although I guess we could take a couple questions.
Yep, looks we have a couple.
Yeah, we have more than a couple, don't we? So I'm not sure where to even start. So
some have been answered.
In regards to the 64-bit A100 GPUs, so there's a standard NVIDIA A100s. They do have what NVIDIA calls a tensor capability, and that's where part of the performance comes from. If you just do plain 64-bit math without tensor cores on the A100, it's a roughly 7 teraflop part, I believe. And whereas if you have the 64-bit tensor capability, it's roughly 19, 20 teraflop part. So the answer is yes. The A40, of course, also has tensor capability, but not the 64-bit tensor core. P64. Okay, I think I answered the network question. And
there's a question about virtualization of the A100s, which I think was referring to the MIG.
Right. So MIG is a little different than virtualization. It actually is splitting up the GPU into separate hardware protected spaces. So we haven't got one in our hands we haven't been looking at one in our hands, the ones that we'll be getting. So we don't have all the answers to how this will work, but it will effectively be separate, like 7 separate GPUs. The configuration of the MIG setup can be changed at runtime as long as the GPU itself is idle. So we'll be able to change how they're split up depending on the request to some extent. All right. Other questions? We do not have any plans for 80 gig versions of the A100s at this time. Slingshot, let's see. So Open Fabrics is the primary interface for Slingshot. That's what MPI will be coding to. GPU direct support, that is in the works. Let's see.
Right, OpenMPI, I would guess, is our probably.
Yes, just working through that. We probably will have, the Cray programming environment as part of our system, so that includes the Cray MPI, but we will also have the OpenMPI library as well, which will probably be our more standard one, actually.
Mm-hmm. I don't know if we can answer the last one.
You want that one, Greg?
I don't know if we can answer it. I don't know what we'll have, but GNU 10, I know there's a range of support between GNU 8 up to GNU 10 and beyond, depending on what you want to do for OpenACC. So we'll highlight in a little bit support for OpenACC through other options, but we'll have GNU. Oh,
and
I guess
yes to Slurm.
I guess we should be reading the questions so people who review this later.
Yeah, that's true. So, the question was whether Slurm, it was Slurm scheduled. So yes, it is Slurm scheduled. Do we want to go ahead with your portion now, Greg?
Yeah, we'll move on and we'll see. I don't think we'll answer too many of the questions directly, but we'll probably entertain some more. So you want to? Okay. There we go. All right. So thanks for joining us. And this, my name is Greg Baer, and I'll be presenting a bit about the more the programming environment and other intellectual services that the Delta project will be providing. So we've already had a few questions related to the programming environment. In order to make Delta as usable to as wide a range of communities as possible, and different codes and applications. Within the traditional HPC environment, we'll aim to provide at least the following compilers. And so we'll have GNU, Intel, the AMD optimizing compiler for support for ROCm. So we have both the AMD CPU and then the AMD GPU. To support the NVIDIA GPUs, we'll have the NVIDIA HPC SDK. And for some of you who may not know, that's where you'll find compilers that were formerly known as the Portland group compilers. So you'll find the NVIDIA CUDA compiler along with the Portland group versions of now rebranded as NVIDIA compilers for support for OpenACC, for example. And as Brett mentioned, we will also, and somewhat uniquely, have support from the Cray programming environment. For those of you who happen to be on a Cray system, you know that there is a suite of Cray compilers and a Cray MPI library, and maybe some other Cray scientific libraries that are part of that. And Cray has recently mentioned that they will re-support or continue to, or re-enable their support for OpenACC and along with their OpenMP support. So there's a variety of options here for supporting different ways of exploiting the GPU, whether it be through CUDA, through something like Cocos, which was mentioned earlier, or OpenMP, or the pragma-based, directive-based approaches, OpenMP and OpenACC, or even the newer compiler implementations in C++ or Fortran for support for the standard parallel or the do concurrent. We don't have versions here, but we will hopefully make it easy to install the particular version of the compilers that are needed. We'll be following the leads of San Diego and Purdue, where they've been deploying majority, if not all, of their software on their clusters now using SPAC. We have some experience with SPAC, and we have more experience with EasyBuild, but we'll be using those two package managers to deploy as much of the software as possible. We'll be contributing the codes that we port to the Delta, contribute those recipes back to the SPAC and EasyBuild repos so that other centers can use the versions that we provide. And we also strongly recommend our user community to maybe start adopting the use of SPAC or EasyBuild for packaging up their own software suites and making it easy to rebuild your applications when, for example, we have to do a system-wide update of some kind that requires a recompilation of all the codes. And we'll be trying to develop some support for that as well. Like most of the other centers, we'll be employing modules through LMOD to make it easy to modify your program environments. And we're currently in the planning stages to try to figure out how to most efficiently set up our module infrastructure along with SPAC to make sure that we make it easy to run applications on the 4 different node types and allow for a simple cross compilation on the login node environment, etc. It was mentioned that we will be providing container support. We'll be supporting initially Singularity, and we recently learned that Singularity has undergone not a forking, but a change in how Singularity is provided now with competing versions that we are exploring which one we will actually deploy. We are definitely going to deploy on compute nodes, and after some review, we're going to be allowing the use of Singularity on login nodes as well to make it easier for our users to develop and add to their containers as they go along. We are going to also make easily available vendor supplied containers as well from NVIDIA. Many of you know NVIDIA has a large repository of Docker and Shifter, now Shifter container images for their software, that are the applications that they ported over, or have worked with the community to port over, and AMD is starting to do that as well. And we also plan to make use of NVIDIA's HPC container maker so that once you're on Delta, you can make images that make it easier to deploy your software. And as mentioned several times, we will be looking at support for persistent user tasks on utility nodes to help with workflow orchestration, long-running services, perhaps as databases, or also for more unusual data transfer requirements. As Tim mentioned earlier, part of the one of the pillars for Delta is the ease of use, and one of the ways that we're enabling better use of the system is through science gateways. And so we have formed a key partnership with SGCI, the Science Gateway Community Institute, to develop a Delta-specific gateway, which will make it easier to deploy your software on Delta and get others in your community to use that software. We're also going to be working heavily with the existing gateway communities to move them onto Delta and help them adopt GPU acceleration. And we're also trying to develop ways of promoting training and other activities that allow for scalable support for the gateway user community. And as such, Jay Alameda and members of the SGCI have been doing interviews of existing gateways, new candidates for gateways, and new communities that could be interested in using the GPU. So we've been out collecting requirements. Probably one thing you're most interested in is what resources are available on Delta and how you can apply for them through the exceed allocation process. And so that Jay mentioned earlier, and the window opens, I believe, June 15th. When you look at Delta, you'll see 3 different allocatable resources: a Delta CPU, Delta GPU portion, and Delta storage. So it was mentioned earlier, Delta is really designed to focus more on the GPU workloads, but providing modest CPU resources to support the GPU workflows. So if you have a workflow that you're porting over from the CPU to GPU and you have bits and pieces moved over, Delta is a good candidate for your project. Access to Delta, in this case, these are how projects can and users can access Delta. Of course, we'll be enabling standard SSH with a NCSA Duo multi-factor enabled for the login nodes. For those of you who want to continue using Exceed single sign-on mechanisms, we'll support that as well through the Exceed Duo multi-factor. Please mute if you get a chance, if you just joined. Thank you. With respect to compute nodes, we know it's important. Certain workflows require accessibility to the compute nodes externally. And certainly we will allow external connections if they're initiated from the compute nodes internally. As a side note, we are looking for those use cases where there might be a case for connections to be initiated externally first, which we know is can be problematic for security, but we are looking for those if there are unique use cases. As Brett highlighted earlier, we will be supporting Open on Demand as a mode of accessing Delta, and our authentication mechanisms, of course, will be supported through CI logon. For gateway access, we'll be supporting the modes that are used and are enabled by gateways, and so they're going to be able to use SSH keys with host IP restrictions. We normally don't enable those for users. Normal users are required to use 2-factor authentication. For data transfers, of course, we'll recommend using the service nodes with Globus. So Globus will be our primary method for large file transfers, but we'll implement methods for using SCP and other data transfer tools on the service nodes. And of course, for small transfers, source codes, either through rsync or git pulls, for example, login nodes are, of course, more than acceptable for use. Policies, we are still forming some of our policies, and so we're looking for feedback if you have input. We will be providing, like many other centers, some resources from Delta for instant or quick on-demand access. And so we haven't quite established what the limits will be for the number of jobs, the number of cores that would be available, the number of GPUs or possible slices of GPUs, as we mentioned through the A100's capability for multi-instance of GPU, MIG. We're still forming our queue policies. We know that most sites typically have normal queues that run on the order of 2 days, and that longer running workloads are possible. They have restrictions on the number of jobs and nodes, but are also preemptible. So we're looking at setting up those and looking for feedback as well. Scheduler settings, of course, we'll be implementing implementation of fair share to make sure that we allow everyone equal access to the system. And for quotas, our default home quota space will be 25 gigabytes, which is in line with most other centers. For projects, we'll be entertaining normal requests for up to 500 gigabytes on the center-wide file system, but with requests up to 1 to 25 terabytes by request. And then finally for Scratch, we'll be looking at normal quotas for around 1 terabyte, but we will be entertaining by request larger quotas up to 100 terabytes. May not be for the whole period that you're on the system, but maybe for, if you have a campaign going on, we might entertain increases in quotas for that. Note for our system, Delta will not have a purged Scratch file system, so we're hoping that our users maintain best practices and try to avoid having data hanging around for a long period of time and using bytes that could be used by someone else. Collaborative services for help. You want to port your code to the GPU and you're looking for assistance. As Tim mentioned earlier, our primary support mechanism was going to be through ECSS. And as was noted earlier, the transition away from Exceed to the new form for access has changed some of the support mechanisms. So we are encouraging projects who are interested in taking new workloads and moving it to the GPU to consider applying for ECSS support on other systems, for example, Expanse or Bridges 2, and using the ECSS request mechanism for getting support. And one would need to do that before the end of somewhere in the second quarter of 2022. Delta itself will have some staff available for support. Most of that's going to be in a much more limited and shorter term engagement, just due to the lack of scalability for support. To address some of that, we'll be working on training events. Like the other centers will be collaborating a lot with other Exceed sites, PSC and Exceed, working a lot with NVIDIA and AMD on collaborative training events as well. And many of you are probably wondering how to get involved in Delta. In the early access program, we usually have a period of time where we look for workloads that can help us stress test the system a bit, look for hardware that might be not as reliable as others. And so we will have an early access program sometime in early fall. The eligibility for that, since it's a kind of a collaborative thing where we benefit from you running on our system, but you also benefit from getting early access. We are looking for workloads that are basically already to run on the GPUs or nearly so. You've been porting your code and you're close to getting it done. That would be fine too. So if you're interested, you can send email to help+delta@ncsa.illinois.edu, and we'll put you on a list for contact once we get closer to the time when we know when exactly our early access period will start. All right, and now we have time for more questions. Okay, Jay, do you want me to read them?
I think that'd be great, Greg.
Great. All right. Will kernel profiling enabled? So you're referring to actually being able to profile kernel calls. I anticipate that probably, like other sites, they will not allow kernel profiling. I've done a lot of profiling with applications, but I can't say that I've ever had to dive into actually looking at the kernel. But that's something that we can entertain. We might be able to provision a node or two where we might be able to provide that level. But offhand, no, I would say that's probably not the default behavior. Let's see, we already answered the early user allocation or process, so we did address that. So I would say for Exceed users at Illinois, you're going to want to continue with getting allocations through Exceed. Illinois does have its own allocation process, but it's a much smaller allocation pool. Brett, I don't know or Tim, if you have a comment on that, or Jay.
Nothing really to add. No, I agree. If you already have Exceed allocations and you're familiar with that process, it's certainly a much bigger pool of resources you can get access to on Delta. So I would definitely start there and go through that process. But I mean, perhaps there are some use cases or scenarios where it might make sense to use the Illinois allocation.
Okay. Let's see, follow up to the question on early user. Is there a way to test performance and scalability prior to applying for an allocation? Well, the early user period would be 1. And Jay, I think, do you have I know there are other allocation processes in Exceed that probably help with that.
Well, so if the machine were here, of course, we'd encourage startup allocations. That's a very natural thing to do, and the preferred thing to do if you have not had a production allocation yet. If you do have a research allocation, you can, and the machine is here, you can request a supplement to that existing allocation and of a startup scale, and then get access to the resources. Of course, in the situation that we're in right now, where the machine is not on the floor, I would recommend doing some initial performance work on the existing GPU resources. So that would be Expanse GPU and Bridges 2 GPU, just to get a baseline of performance. And then when the machine appears, then you can update those results.
Okay, thanks, Jay. All right, and the final question that we have here from Mark is the NVIDIA Exceed GPU hackathons are great, and I would agree. Any plans for new ECSS to adopt a similar approach? And I'm not too sure what you mean by new ECSS. Is that part of the follow-up to ECSS and after Exceed? I'm not too sure. Okay. I'm not too sure I can address that. Maybe someone else can.
Well, so we've talked about having some hackathon type activities within Delta partnering with NVIDIA. As far as ECSS, I mean, that's not a question I can really answer. As far as subsequent to Exceed, there isn't really an analog for ECSS in the Access program at this point. So when Exceed ends, we would expect those activities to go away.
Okay. Okay, here's a question. So yeah, so I do agree. In Delta NVIDIA hackathons will be great, and we will strive for those. Sandy Campus will be helping orchestrate those. And the question is, is there going to be an equivalent to the Blue Waters Fellows for Delta? And I believe there are Exceed fellowship programs, but I don't know. I don't know if we're not going to have one specifically for Delta, I don't believe. All right. Well, we have time for a few more questions, if there are any. What does it sound like? Oh. Will there be, let's see, Mark's asking, will there be GNU development nodes? We might need a little, unless someone knows offhand what you mean by a GNU development node. Oh, GNU, GPU development. So we kind of had that, we were having a discussion about something similar to that earlier. I believe you would want to be using the kind of instant or on-demand resources that are available to do that kind of work. Otherwise, compute nodes will be where you find the GPUs. We won't have GPUs hanging off of the login nodes or service nodes. So hopefully we configure the instant, quote unquote, instant or on-demand resources appropriately to satisfy those requirements.
And that might well be a good use of a MIG slice as well. It's one of the reasons that we think MIG will be very useful, to give you just a little bit of the GPU without having to pay for the whole thing. How do you manage to, how do you plan on managing MIG with Slurm? That's a very good question. One that we don't fully know yet. NVIDIA has a plugin for Slurm that they have made available. We don't obviously have it really to test at this point, so we're not completely sure how well it will work. But there is also work being done by SCADMD on a more robust implementation, is our understanding. So This is something that we probably won't be able to do a lot of development on ourselves until the hardware arrives. And so it probably will be something we'll still be working on during the early user period. Are the CPU nodes and GPU nodes going to be under the same Slurm cluster or distinct ones? I'm not sure if I understand the terminology there exactly. They'll certainly be under the same Slurm instance. I think we plan to schedule them separate. Well, we plan to have them in distinct resource pools, if that's the question.
Right. So I guess maybe if we wanted to say, if someone wanted to co-schedule a certain number of CPU nodes and a certain number of GPU nodes, that would maybe, so that should be possible.
And I guess if you've looked at the resource description on the Exceed site, you will note that the CPU and GPU portions have separate allocations. So you need to request those distinctly in your allocation request. And so they'll be separately charged as well.
Any more questions? Guess we should hand back to you, Jay.
Certainly. Thank you very much, Tim, Greg, and Brett. And thank you, everybody, for coming to our first introduction to Delta training today. I hope that this proves to be a useful and interesting resource for you. And we look forward to seeing your allocation requests, and no matter which channel you come in.